Okay, so we are now recording. Right, so we have a new topic for this day, and it's all about capacitors and inductors. Okay, so um, we know earlier in our discussion of electric circuits that there are two types of elements in a circuit. You have your active elements and then you have your passive elements. And so far, we only have discussed active elements. No? So you have there your sources and your resistors. But we also have passive elements in a circuit. And these are the capacitors and the inductors. Okay? And these two elements are supposed to store energy. Okay, so how they store energy will be introduced later. So for starters, know what is a capacitor. So it is basically made of two conducting plates separated by an insulator. So you see here, we know this no, from physics. So you have two parallel plates there, and there exist charges on either side, positive on one side and negative on the other side. So this in this case, no, the insulator of this basic capacitor is air. No? But others, no, they have other capacitors are have different insulators as ceramic, paper could be one, fish paper, and all the other insulators that can be used here to separate the two conducting plates. Okay, so if it is connected the voltage source, the source then that source deposits positive charges on one side and negative charges on the other. Okay, so that basically is your capacitor. Okay, so capacitors store electric charge. Okay, so here your electric charge that we learned from our physics that if you have two charge plates, no, with opposite charges, then electric field, no, will exist between these two charges. So in this case, now we have that electric field. Okay. Okay, and it is in this electric field that the energy of the resistor is capacitor. I mean, is stored. Okay, so that is your capacitor. So that is how it stores its energy. Okay, so the amount of charge you stored is directly proportional to the applied voltage. So this is basically the foundation of your capacitor, that Q is directly proportional to the voltage. So the more voltage that is placed, the higher the voltage that is placed there um, on either plates of the capacitor, the more charge there is. And the ratio between this charge to the voltage is what we call the capacitance. Okay, and that is measured in farad. No, so in honor of Michael Faraday. Right. So that is your capacitors. So here, current flows into the positive terminal of the capacitor with discharging and out of the terminal when it is discharging. So your capacitors charge and then discharge. Okay, so charge and then discharge. So of course it charges when there is a voltage across its terminals, and then it discharges when it sees load. Okay, so that's why in older types of TVs, kanang mga CRT na TV. Are you familiar with the CRT or TV? Kanang TV nga nabako sa likod, no? So most of the TVs nowadays are flat screen, no? Pati ang likod flat. Okay? So nipis na kaya mga TV, but those TVs that were used before are are using the concept of a cathode ray tube. Wherein electrons are fired using the cathode ray tube and fired into the phosphor coated screen, no, the inside of the screen. So whenever electrons are hit the surface which with phosphor coating, the electrons it gets excited and emits light. Okay? So mo na siya ang imuhang capacitor. That's why if you see older movies, no, if you see older movies, if you see a screen there, no, sa mga old na movies, what you see is murag na ay naga-trace ngayon na, no, na light. So makita ang delay dito, no, sa movie. Okay, so that is because this is how the cathode ray tube fires electrons on the phosphor coated inside of the screen. Okay, so in order to do that, you need to have a very a large ano siya? You require a larger energy. In order to have that energy, then you have to have a larger voltage across the plates. No, it has plates here inside in order to redirect the the firing of this capacitor. So sa una among mga TV na siya mga vertical hold and horizontal hold, no? So na siya mga knobs to sa likod. So we can ang katong vertical and then horizontal hold we can uh, decrease or increase the width or the length of the what is shown on the screen of the TV. Okay? So, ano siya ang ginagamit dito. And also, again, in order to fire that, you need a large amount of energy. So, in a cathode ray tube, no, you have what they call the flyback capacitor. Okay, so this flyback capacitor stores a very large amount of energy. So even if the TV hasn't been used for a long time, there is still that energy that is stored in the flyback capacitor. So that's why you often see your TV at the back nakabutang dito, no? TV monitors sa mga computers before do not open unless you know, unless you are a certified technician, no, or inside, no, nakabutang dito, do not open this or touch this unless you're a certified technician, because the energy stored there is very large, and if you um, touch that and you are connected directly to the ground, no, or sa table, no, which is connected to the ground, then dako kaya nga energy ang imuhang ma-feel, no, by electrocution, no. So muna siya ang mga experts ani nga mga technician, what they do is they have to release, no, that energy, no, by connecting the capacitor to ground, no, to release that amount of energy. Okay, so that's how big, no, the energy that can be stored in a capacitor. So that's why ang ilang ginaisip, no, they some concepts, no, ang gina-float na to use capacitors, no, as a storage of a large amount of energy that can be used. Okay, I don't know how it prospers, but I will let you to be the judge, no, on how that is conducted. Okay, so we know, no, from our previous discussion that current is equal to is the change or the amount of charge that is passing through the area, no, cross-sectional area of a conductor per given time. Okay, or that could express the differential equation that is I is equals to dq over dt. Now, if we from the relationship, no, between a capacitor and the voltage, no, Q is equals to CV, and then we substitute it here. Okay, so that becomes C dV over dt. No, because we factor out C here, because this is a constant, no? So I become C dV over dt. And this equation is what you call the current voltage relationship, no, of your capacitors. Okay? Okay, so I is equals to C dV over dt, the current voltage relationship of your capacitor. So in order to get in order to get the voltage current relationship, we simply rearrange the equation and solve for V. So that becomes 1 over C, the integral of I dt, okay, um, evaluated from negative infinity to t. No, why negative infinity? Take note, even if the capacitor is stored for a longer time, there is still that energy that is stored. There's still that voltage that is present on the terminals of your capacitor. Okay, so however, we only consider if we only consider at t is equals to 0, and consider that voltage, at t is equals to 0, as the energy that is present or the voltage that is present in the capacitor, then we could have, the equation for the voltage as 1 over C integrated from 0 to t, oh, I dt integrated from 0 to t plus V over of t0, which is what we call the initial voltage, of your capacitor. Okay, so if the capacitor has been discharged and therefore the voltage there is equals to 0, at t is equals to 0. Okay. So the instantaneous power there in your capacitor is P is equals to V times I. So that is equal to C V dV over dt. Okay, so just substituting the previous equation, I is equals to C dV over dt. So the energy stored in the capacitor is integral of P dt, from negative infinity to t. Okay, or that is C V dV over dt times dt. So dt cancels out, so that becomes C times integral of V dV evaluated from negative infinity to t. Okay? So therefore, umantay, ano siya? We evaluate this, no? So that becomes 1/2 CV squared of evaluated from negative infinity to t. Now, since we don't have that t here, we can just make use of this equation. Okay, so that is 1/2 CV squared, for your energy stored, or that is also equal to Q squared over 2C, when that is in terms of Q, right? So that is how you determine the energy that is stored in your capacitor. So just a quick summary. A charge is equals to CV. The current is equals to, capacitor is C dV over dt. The voltage is 1 over C times IDT, integral of IDT integrated from T sub 0 to T plus um, the initial voltage at T is equals to 0. The power is equals to C VdV over dt, and the energy is equals to 1/2 CV squared or Q squared over 2C. Okay? Right. So these are now the properties of capacitors. No? So of course, we consider first, what is its um, ability, in or capacity. Yes, ability when it is at DC. No? So a capacitor is an open circuit at DC. Okay? So open circuit daw siya at DC. If a voltage is constant, the current across it is equal to 0. No? So, na-memes gaya na siya kung saan na siya? In the Facebook, no? So, kung current daw, moagi diri, so di siya kaagi, open man siya diri. So, that's why current is equals to 0 in if the voltage is constant, no? Across in a capacitor. But since AC is not constant, so ingon nila, moana ra daw ang current moagi dito and then pass through like that. No? So, muna siya ang meme that is shown in what do you call this in FB. I saw one in FB. Property number 2, the voltage on one capacitor must be continuous. So no instantaneous change of voltage, but current may change instantaneously. Okay, so a voltage could not be, or the voltage on a capacitor must be continuous. Okay, so this one. Okay, so meaning wala siya dapat nag-zero. Okay, may mahang voltage. There it goes. Another, an ideal capacitor does not dissipate energy. So it only takes power from the circuit and stores it. No? It returns previously stored energy when delivering power. Okay, so muna siya tung sa positive half cycle and negative half cycle. If in your electronics one, you will in the design of sana siya kanang power supply, no? Using bridge rectifier. So sa bridge rectifier ninyo, what you will get, no, is still naghapon siya, no? Naghapon. So this is 0. So naghapon siya dili gyapon straight line, no, ang after rectification using bridge rectifier. So in order to filter, no, this line here, you need to have a capacitor, no? So para pag sa positive niya na half cycle, okay, mag-charge siya, okay, and during the 1/4 cycle na mag-start na mag-zero ang imuhang what do you call this, ang imuhang value, or mag-decrease na imong value, no, sa ana, you have that as your AC signal. Okay, so this is your x-axis. This is the positive half cycle, and this is the negative half cycle of your signal. So pag positive half cycle, mag-start na siya og charge imong capacitor. And then after still on the positive half cycle, pero nag-decrease na ang imong voltage, so mag-start po na siya og discharge. So that's why sa imong in filtering the signals in your bridge rectifier, iyan ang punan diri. Okay, so punan ana. Yan. Okay, punan niya diri ang imong signal. So that is why ang mahimo na signal nimo diri is filtered na siya, murag ana na imong signal na magawas, no? If you view that signal in a oscilloscope. Okay, so mo na ang magawas. So muna siya ginaingon na it takes power from the circuit and stores it, and then it returns the power previously stored energy when delivering power. So that in this from the peak, no, of your positive cycle, mag-start na og naog ang imong value, mag-start na po na siya og discharge sa iyang energy. No? It delivers energy, no, to the circuit. Okay, so that is the third property of your capacitor. Here, what is the voltage across 3 microfarad capacitor if the charge on one plate is equals to 0.12 microcoulomb? Okay, what is the voltage? So Q is equals to C times V. Okay, so therefore voltage is equals to Q over C. So is 0.12 times 10 to the negative 3. Okay, and this one is what is this is millicoulomb, no? And this is microcoulomb. So kung milli is -3, micro is -6. Am I correct? Okay, so this is 3 times 10 to -6 coulomb and farad. So what would be the answer? Is this equal to 40 volts? Ano na yung nagasulod? Can you compute this? 0.12 divided by 3 raised to the 6. Is that correct?
Yes, sir.
Okay, so this is equal to 40 volts. Am I correct?
Yes po.
Okay, and then your energy is equals to 1/2 CV squared. Okay? Or this is also equal to ano yun? Q squared over 2C. Okay, so this is 0.5 times C is 3 times 10 to the -6 times V is 40. So is that equal to 2.4 millijoules? Okay, or this is 0.12 times 10 to -3, excuse me, squared divided by 2 times 3 times 10 to -6. So are these two values the same? Is this both equal to 2.4 millijoules? Okay. Anybody? Is this correct? Is this 2.4 millijoules?
Yes, sir.
Okay. So just take note that um, capacitance is a very, very large value. So that's why you often see ang kaning mga values nila in the factor of micro and milli. Sometimes nano. Okay? So a small capacitor will be able to provide a larger amount of uh, energy or store a larger amount of energy. No? So take note that, again in the properties, the third property of capacitors, it can only release this capacitor if ano yun? It is connected to a load. Okay, if it is connected to a load, and if it is disconnected from the source. Okay, it's connected to the load and it is disconnected to the load. So that's why you often see, no, ano mga ingana, it is always connected in series, no, with a load, and the load is, and the resistor is considered as your load. Okay, so kani siya i-discharge na niya dito, no, sa imuhang resistor, no, ang iyang energy. Okay, so that is how your capacitors deliver energy. This one, if a 10 microfarad capacitor is connected to a voltage source with Vt is equals to 50 sine of 200t, find the current through the capacitor. Okay, so current is equals to C dV over dt. So I is equals to 10 times 10 to -6 times, what is dV over dt? So dV over dt is derivative of 50 sine of 2000t times dt. Okay, so what is the derivative of sine? That is cosine. 2000. This is 2000. So this is 50 cosine of 2000 t. Okay, so times, am I correct? Times 2000 pa to, di ba? I'm sorry. Times 2000. Okay, ang derivative d of sine, ano ba yun? Sine x t is equals to x cosine of x t. Correct? All right. So, just enter it here. 50 times 2000 times cosine of 2000 t. So, is this equal to cosine of 2000 t? Anybody? Hmm? Is this equal to 1?
Yes, sir.
Okay, so cosine of 2000 t amperes. Okay, so just a few examples. On this one, an initially uncharged 1 millifarad capacitor has the current as below. Calculate the voltage across it at t is equals to 2 milliseconds and at t is equals to 5 milliseconds. Okay? Under DC conditions, find the energy stored in the capacitor. Okay? Kindly ano this, itong dalawa, take note ang katong previous nato nga topic no sa first chapter, no? And how do you what do you call it? Ayan. How do you solve for values using a graph? Okay, so this one is time current versus time. Okay, so take note that your I is equals to C dq over dt. Okay, and your voltage is equals to how much? Ano yung formula for voltage? 1 over C. Go back, kalimutan ko. 1 over C. And integral of I dt at 0 to t plus v t is equals to 0. Okay? So, take note here na initial value is 0 and at starting at t is equals to milliseconds, nag-continuous na ang signal. Okay? So, what is the voltage across at 2 milliseconds? Okay, you go back to your chapter 1. Example number 4. Under DC conditions, now find the energy stored in the capacitors. So how many capacitors do you have? So you have 20 microfarad capacitor and a 10 microfarad capacitor. Okay? So, uh, take note the energy is equals to 1 half CV squared. So we already have the values of your, what do you call this, capacitor. Okay? So, ang dire, no, what will be the voltage, no, across that capacitor? No? So, in both cases, no, for example number 3 and example number 4, no, we make use of these properties. First property, a capacitor is an open circuit at DC. So, if a voltage is constant, the current across it is equals to 0. Okay? So, kung open circuit siya sa DC, then therefore, it seems that these capacitors, no, these capacitors here, are kung tanaw mo nimo siya at DC, they are not present, no? So ang current nimo mo ana na siya. Okay? So that is how your current flows. Okay? And the voltage, no, across the capacitor is equal to the voltage of the resistor connected in series, in parallel with that capacitor. Okay? So, therefore, here in this problem, you have to, for the 20 microfarad capacitor, you have to get the voltage across the 3 kilo ohm resistor. And then for the 10 microfarad capacitor, no, since mo ni ang iyahang terminals, then the series combination of 3 kilo ohms and 6 kilo ohms and the voltage on both here, since additive ang voltage when they are connected in series, then that would also be the voltage across your 10 microfarad capacitor. Okay? Claro? Okay. So, that will be your sit work for this morning, but you will solve that later, after our discussion of other concepts, with capacitor. Okay, so if you notice here, capacitors also are connected, as an element, in your circuit. So they could either be connected in series or they could also be connected in parallel. So here you can see that the equivalent capacitance of capacitors connected in parallel, is just opposite of that of your resistors. So this equivalent capacitor of capacitors connected in parallel is equals to C1 plus C2 plus C3 plus dot 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 plus Cn. Okay? That would be your equivalent capacitance of capacitors connected in parallel. Okay. While capacitors connected in series follows that of the resistance connected in parallel. Okay? So 1 over C equivalent is equals to 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over Cn. Okay? So muna siya ang imuhang capacitor. Okay? So connected in series or parallel. So opposite siya, sa mga what do you call this, sa capacitors, sa formula ng resistances. Okay? So yun na siya na. So just put that into your mind. So here, so kamo na bahala mag-solve ani. Okay? And it's the same seat work with siya. So this is seat work number 3. Okay? This one, find the voltage across each of the capacitors. Okay, so answer V1 is equals to 30 volts, V2 is equals to 30 volts, V3 is equals to 10 volts, and V4 is equals to 20 volts. So, giyon sa na siya pagkuha. So, it follows, it still follows ang kanang, what do you call this, voltage division formula. Okay? So, voltage division formula. Now, take note, ang kaning 40 nimo Okay, so here, so yun. So 33, then 30 po diri. Parang mali siya, no? Then this one is V3 is 10 and this is 20. So because you still have to get no, the combination no, of this one here. No? So i-combine pa rin mo sila before you can solve the voltage across this V2 no, using the voltage division formula. Okay? So I suppose the equivalent here is equal to 40 microfarad. Okay? That's another seat work. Okay, so we now, ano ba tayo? So what time is it? We have 10, 11. So I'll give you that time to solve for this seat work. Okay? So himuan ako siya og ano ha? Himuan ako siya og kanang what do you call this? Classwork. Okay? So this is number 1. I'll just screen capture. Okay. This is number 2. Ay, tama ba yun? This is number 1. And sorry, this is number 2. Number 3. And this is number 4. Okay? So, ako sa siyang stop ang atong ano ha, ang ato ang recording, no? So, on the next session, no, we're going to start with inductors. Okay?